Hi boys and girls, it's me Butch. My name is Terry David Silvercloud. I live in Vancouver, British Columbia. I'm 73 years old. I have chronic pain issues with arthritis, so to kill time, because I live alone, I work in my art and do things where I can be sitting down these days. And making videos is one of them. So I assume you're here to learn a bit about energy. What is it? Where does it come from? That kind of stuff. So I'm a theoretical physicist, and theoretical physicists people are the kind of people that are either trying to prove or disprove existing theories. Like a lot of people assume Big Bang theory is correct, but there's there's probably more people busy disproving it than proving it, and Big Bang is a theory that's been going nowhere for a long time, and I don't believe in it. So now you know where I stand. So as a physicist who really cares about science, I get really upset when I see all the bad science that gets pushed around out there. So if I'm telling you my opinion, I'll make sure I tell you it's my opinion. You don't have to believe it's what I think. I don't care what you think, because I'm always right. I'm Butch. So, like, I saw a movie years ago. It was called something like What the Blink Do We Know? And it was shocking to me, because most of the science, or so-called science, was total BS. It wasn't any kind of science, but the people watching it who wouldn't have the kind of education that I have would definitely be inclined to believe, oh, this has been proven. See, I saw it in the movie. But what you see in movies is not necessarily real. A lot of you will have ideas of every time you see a movie with Egyptians in it in the past, there's going to be pyramids, but what you may not know and probably don't know is that the pyramids were built during a very, very, very short period of Egyptian history, and it was really ancient. And the pyramids, besides the squabblings between the pharaohs and the priest class, the pyramids proved not to be invulnerable from theft, and shortly after they were built as presumably tombs to keep the riches of the pharaohs intact, they were plundered by the succeeding pharaohs and priests and anybody else that could find their way in. So by the time of Moses, which in the Christian, Jewish, and even Islamic faiths would have been a long time ago, but even in the time of Moses, the pyramids had been around for 1,000 years. So it's easy, if you don't study things carefully, to get a little confused, and a lot of fallacies of ambiguity creep in where what you think is real isn't real. And if you're not an actual real scientist who knows a thing or two, you really won't know whether the wool's being pulled over your eyes or not. And I'm supposed to be talking about energy. So energy is the ability to do work. And energy derives from a fundamental reality around us. Several, but upon one is that nothing sits still. Why that is generally believed to be because of gravity. And we've been studying gravity. We have all kinds of terrific rules for it. We know lots about gravity, but we don't actually know what causes it. And generally speaking, it's believed to be attraction between masses, and we can measure it, and we know that an elephant and a mouse will both accelerate both at 32 feet per second, falling upon to the surface of Earth, and the elephant and the mouse, disregarding air resistance and that kind of stuff, will both go splat at exactly the same time. But we also know the elephant will make a much bigger splat, so stand clear of the elephant when it goes splat, because it's going to have more impact. And we even know how to measure it. We could tell you If you had an actual elephant, we could measure exactly how much splat it was going to make. That's how good we are with gravity, but we don't know what caused it, except that somehow the elephant was attracted to the earth. So as you sit or stand or whatever you're doing, listening to me, you are pushing against the earth with your weight. That is the amount of energy you have. That is your inertia. And all things are in motion, and all things are seeking rest. Rest is no motion, but there isn't anywhere in the entire universe where there is no motion. No motion is always relative to something else. I'm sitting on the chair, but the chair is attached to the floor, and the floor is attached to the apartment building, which is attached to the earth. And the earth is turning, and all of that spinning is keeping me attached with my weight, which is around 200 pounds, to my chair. So motion, energy is things, different values of energy trying to achieve equilibrium, where the pushing and shoving would, in a theoretically still not moving universe, or almost not moving universe, everything was pushing equally in all directions, everywhere, all at once, all the time, and then in theory the universe might come to a halt. But it won't, because no two things can occupy the same place, and even if somebody just a few things down leaned to the right, even though that each succeeding person would not really go anywhere, they would still sway. It would be kind of like the spectators in the stadium, where you can see the wave go across the stadium, but all it really involves is one person standing up and sitting down. If every single person were the same height and the same weight, then in theory it would take exactly the same amount of energy. That would be the energy that was being passed, even though the individual person didn't go anywhere. So electrons, which transmit just about everything we know, they behave that way. In alternating currents, they don't much go anywhere. They just vibrate or rotate differently, but they don't much go anywhere. The only time electrons actually move in electricity is in direct current, and even then they don't move that fast. If you can imagine a pipe so thin that only one electron at a time can get through the wire, if you put an electron in one end of the wire, at that very instant another one would pop out at the speed of light, but the first electron would just be making its way along at its diameter. So Butchie Poo, and make sure I'm telling you this is my theory, Butchie Poo says that is why the physical electron sets the speed of light and is actually the source of energy. Because when it comes in physics to the fermions and the leptons, which are the solid kind of things, the very smallest one of the three major ones, the electron, the proton, and the neutron, is the electron, and we know for a fact that it repels itself, and that it also has physical size. And even if there was something smaller, if this was the electron, even if there were smaller particles, and there could be, I call them gamma particles, that's my feeling, or even if they were neutrinos, that the smaller ones would not really be able to move even an electron, even to get it going, unless there were a number of them pounding on the door at the same time. So Butchie Poo, this is my theory, so you don't confuse it with accepted theory, because it's my original theory, is that electrons are monopoles. We know they're monopoles. So I'm just describing something you can observe. You just observe them. It's been in front of us all the time, but nobody's ever really connected them to being the cause of gravity, the cause of all energy, by their pushiness. And you may say, well, what about quarks and protons and neutrons? Well, they push too. They're just bigger. So they may not, they may have more of the same, they could be built of the same thing, as the electron, but they're fairly big and stable, and we know that electrons just love clustering around them. So if the electrons are seeking a place of rest, then the surface of protons and neutrons, which seem to be quite stable, extremely large, almost to 1,836 times their mass, which is their weight, electrically, then the reason electrons may cluster around protons and neutrons is simply because we know they don't. You would think the proton being positive, the electron would just plow right in there like it just come to the local brothel house or something, but it doesn't. They never join up. Even a single proton and a single electron, they never join up. The electron forms a stable relationship with the proton, which we would call hydrogen, and it remains as a gas. And if somehow it should become a solid, it would become what we would call a neutron, and we know that because when a neutron decays, it will spit out an electron. So my idea is that protons are almost a torus, but there's a space in them that is just big enough for an electron to lodge itself into, and I think electrons, this is my theory, are icosahedrons, that's a point of rest from the point of view of the electron. It would be the least motion, and it could get, because it's pushing away from everything, it would cause energy. But in physics in general, accepted theory, energy is the ability to do work. So wherever something has more energy than something else, the thing that has more energy is the pushier of the two and can push the lesser one around. In the world of reality, might is right. That's why even though electrons, I say, this is what I'm saying, even though they're teensy tiny little suckers, there's more of them together in the universe. This is for real. I'm not making this up. There are more electrons than there are protons and neutrons, and the reason I can easily say that is every neutron already contains an electron, so they don't even count. So every neutron has already neutralized itself out of the head count because that counts for an electron already. And then there's still way more electrons, and even though they may be small, when you get the army together with a bunch of little guys, you better watch out. Those little guys can be really tough. The Romans, they learned really on that might is right, and they developed some tactics. They developed a slightly extra long spear and also a two-edged sword, and this tactic called the turtle, where every guy had a shield, roughly 2x4, and thick enough to stop any sort of arrows and stuff, but light enough you could carry it. And when they went into battle, they just, the guys in the middle all put their shields up for the roof of this sucker, and the guys all around the edge, they just made a wall, and they just stuck their swords and their extra long spears through there, and they just went straight forward. The extra long spears, I think the Greeks invented that. Where was I? I get astray here. So energy is the ability to do work. And where it comes from is there is a weak force. Every physicist, every real physicist would admit there's some kind of force, and it's called gravity in the world of real physics. In spite of the fact that it's probably the most weakest force that we know of, when you start adding up the numbers because of how small atoms are, the force of gravity becomes exponentially larger with how big something is. If you thought of it in reverse the way I am, that the bigger you become, the more pressure you have on you, but the more ability you have to push back against it, then to me, being able to get bigger, and we know this from physics, is that for an electron to move from an inner shell to an outer shell to make that quantum leap, it has to gain energy. It has to get more energy. The atom has to, it's not really inflating, but it's sort of inflating. The electron is moving outwards. They don't normally do that unless they're on the outermost shell, and then they quite often leave the atom either briefly or sometimes for a while, or they suddenly start reacting with another atom and they start sharing the way they're built and the way the electrons are there. I'm up to 50 minutes and 38 seconds. What did I really want to cover? I just want to talk to you about energy today, and caution people. I'm really against the idea of the people out there spread this free energy thing. Nothing's free, because somebody's going to have to build and maintain or buy and sell whatever it takes to convert one form of energy to another, whether it's the electromagnetic waves coming from the sun, or whether you want to harness heat waves in the earth, geothermal. They're all waves. There's a point at which physical waves and electromagnetic waves become entwined, and it happens when wavelengths in the electromagnetic band are about 1 micron long, and in that area, 950 to 1000 nanometers, that happens to be about the same size as a lot of atomic structures and molecular structures. And if you start getting hit by any kind of wave, whether it's physical or electromagnetic, that is more or less the same size as you are, it's like the soldiers going over the bridge, you're in a serious earthquake. This is an earthquake you may not survive. And so if atoms are all joined together, they're trying desperately to rip themselves apart from the adjoining atoms, and the electrons are they're jumping in and out of their orbits and releasing units of energy called photons, which is a unit of energy, and those units of energy build up and it becomes heat, and the heat expands air, which becomes light, and you got yourself a good old fire going eventually. How did I get into that? The point is to get further out from something. Why I say the universe is push, not attraction, is to get bigger you require more energy. And the reason I say the electron sets it is, it's basically the smallest unit, which is extremely active in the universe, and it gets its ability by taking, this is what I'm saying, by taking on the shape of an icosahedron, and that even if there are smaller particles, which would be could be gamma particles and neutrinos and such, it wouldn't matter. They would be simply little bits trying to push the larger stable electron, and the icosahedron is much more stable than a sphere, which I'm not going to rattle on about here today, because I just wanted to go on a bit about energy and where I think energy comes from, and to entertain you a bit. And I'm up to 18 minutes, so I don't know if I covered what I wanted to cover, but I killed some time, and I hope I made myself useful. And I mentioned photons, and sometimes I get answered questions on this Quora website. One of the most frequently misunderstood concepts is photons. Photons are not particles. In order to unite the world of quantum physics and the world of particle physics, there is an agreed upon terminology. And in quantum physics, they don't much really give a crap about particles, because everything's a wave anyway. But in order to assign a particular kind of wave characteristic and units of energy, they base everything upon an electron. And an electron being the thing they use, we use electrons to measure everything anyway. In order for an electron to make a complete sine wave, it would have to roll its entire circumference, so its existence is measured on only half of its circumference, which is called a half spin. So by definition, things which are solid and not bosons, photons are bosons. They're things that are units of energy, but they don't have physical anything. They can actually exist in the same place. A boson can exist in the same area as something that is actually solid, but no two solid things, leptons or fermions, can be in the same space at the same time. So the terminology comes from trying to unite wave physics with particle physics, and in particle physics they believe in actual particles, as I do, and they give them names like quarks, and the quarks, in order to align them with quantum physics, which is the only real way to deal with the suckers anyway, because the motion is so complex. Quarks are given quantum values, and everything really in quantum mechanics is based around the characteristics of the electron, which is a very good thing, because Butchie Poo, me, this is my theory, is a monopole, which we know already, and because of that characteristic of trying to get away from everything, and no two electrons can share the same space at the same time, that's the Pauli principle, because they're solid things. They provide the pressure of the universe, and it's extremely small, and gravity is push, not pull, to me. I'm up to 21 minutes. I said I was going to shut up. My nose is clogging up, so I must have smelled something. I'm very sensitive to smells. It's not a cold. But here I go. I got my thing on the stop button. Bye from Butch.